Welcome to the world of Neptune. Neptune is the eighth and most distant planet from the Sun in our solar system. With a diameter of about 30,600 miles, Neptune is approximately 4 times wider than Earth. The existence of this ice giant planet was mathematically predicted before it was directly observed. Irregularities in the orbit of Uranus led scientists to theorize that an unknown eighth planet existed beyond it that was gravitationally affecting its orbit. On average, Neptune orbits the Sun once every 164.8 years, with one Neptunian year equal to approximately 60,190 Earth days. The planet has an elliptical orbit that takes it between 2.8 billion and 3 billion miles from the Sun. It is the only planet in our solar system not visible to the naked eye from Earth. Neptune forms the outermost boundary of the solar system's planetary region, more than 30 times farther out than Earth's orbit around the Sun. Neptune revolves on its axis once every 16 hours, faster than Earth's 24-hour rotational period. Like Uranus, Neptune rotates in a retrograde direction, opposite to the way most other planets spin. This may be due to a past collision event that altered its rotational direction. With an axial tilt of 29 degrees, Neptune experiences seasons resemble Earth's, lasting 40 years each. The tilt also results in day and night cycles similar to other planets. With a radius of 15,299 miles, Neptune is approximately 4 times wider than Earth. However, it has a lower density than our home planet. Whereas Earth is made up of heavier elements like iron, nickel, and silicon, Neptune consists mostly of lighter elements like hydrogen, helium, water, and methane. This gives Neptune an average density of 1.64 grams per cc, lower than Earth's 5.51 grams per cc density. Overall, Neptune has a mass of 1.02 x 1026 kg, about 17 times more massive than Earth. Neptune's outer atmosphere is made up predominantly of hydrogen and helium, with around 2.5% methane. The methane in its upper atmosphere absorbs red light, which imparts a vivid blue color to the planet. High-altitude methane clouds contribute to Neptune's deep azure appearance. Neptune's atmosphere also contains traces of other hydrocarbons like ethane and acetylene, as well as compounds like water, ammonia, and hydrogen sulfide. Temperatures on Neptune can reach as low as 224 degrees Celsius, making it one of the coldest planets in the solar system. The uppermost cloud layers experience the coldest temperatures, while temperatures increase deeper into the atmosphere. At the core, temperatures may reach 5,000 degrees Celsius, hot enough to melt iron. This internal heat powers Neptune's dynamic atmosphere. Neptune's atmosphere whips around the planet at speeds exceeding 1,200 miles per hour, faster than the speed of sound. These are the fastest planetary winds in the solar system. Giant storms churn through Neptune's atmosphere, driven by 600 miles per hour winds. One famous historical feature is the Great Dark Spot, an anticyclonic storm system comparable to Jupiter's Great Red Spot. This storm was observed when Voyager 2 flew by in 1989 but later dissipated by 1994. In 2018, astronomers discovered another new Great Dark Spot in Neptune's atmosphere. In addition to giant storms, Neptune experiences differential rotation. Its equatorial regions rotate faster than the poles. Bands of clouds form and dissipate based on these wind patterns. White, high-altitude clouds often appear as streaks circling the planet. Deeper methane ice clouds display darker colors. Neptune's dynamic storms and weather patterns continue to be studied. Neptune has a faint planetary ring system consisting of 5 main rings named Gaul, Leverrier, Lassell, Arago, and Adams. These rings likely contain dust grains and ice particles up to 10 meters in diameter, and are relatively young compared to Saturn and Uranus's ring systems. 3 fainter rings called Liberté, Égalité 1, and Égalité 2 reside between the Leverrier and Lassell rings. Neptune has 14 confirmed moons. The largest and most interesting is Triton, discovered by William Lassell just 17 days after Neptune itself was found. With a diameter of 1,680 miles, Triton makes up 99.5% of all the mass orbiting Neptune. Triton has a retrograde orbit and was likely gravitationally captured by Neptune. Triton's surface is one of the coldest in the Solar System, with temperatures of -391 degrees Fahrenheit. Despite this extreme cold, Triton has geyser-like volcanic plumes spewing liquid nitrogen and dust particles up to 5 miles high, indicating geological activity. Triton has a thin nitrogen atmosphere and a complex seasonal cycle where the atmosphere condenses and sublimates based on its distance from the Sun. Only one spacecraft, NASA's Voyager 2 probe, has flown by Neptune to date in August 1989. Voyager 2 returned detailed photographs and measurements that revolutionized our understanding of this ice giant. It mapped Neptune's dark spots, observed its ring arches, and discovered 6 of its moons. Voyager also measured Neptune's magnetic field and the composition of its atmosphere and ionosphere. Future missions to Neptune have been proposed, including orbiters and atmospheric entry probes, but none have yet materialized. As the farthest detected planet in the Solar System, Neptune helps define the boundary separating the inner rocky planets from the outer gas giants. Its orbit and interaction with the rest of the Solar System also enables astronomers to accurately estimate the mass of the Solar System and its star, the Sun. Comparing Neptune to Uranus provides evidence into the formation of ice giants as opposed to gas giants like Jupiter and Saturn. Many aspects of Neptune remain mysterious and warrant further study. Future atmospheric probes could provide insights into its bizarre weather patterns and giant storms. The unusual axial tilt and magnetic field geometry are also subjects of ongoing research. Detailed observations of Neptune's rings and moons, especially enigmatic Triton, could reveal intriguing clues about the history of our Solar System's evolution.